How do capacitors correct power factor in AC systems? Imagine a busy factory with many machines running at once. Some of these machines are motors that make the electrical system lag behind the voltage. This lag causes inefficiency. That's where capacitors come into play. They help fix this issue and make everything run smoother. In alternating current systems, the current and voltage don't always move together. Inductive loads like motors and transformers cause the current to lag behind the voltage. This creates a phase difference called a lagging power factor. When the power factor is low, it means a lot of energy is wasted in reactive power. Reactive power is stored and released in the magnetic fields of the inductive devices. It doesn't do any useful work but still uses up energy in the system. Capacitors help by providing reactive power that leads the voltage. When you connect a capacitor in parallel with an inductive load, it supplies reactive power locally. This reduces the reactive power that the source has to supply. As a result, the total reactive power in the system drops. This makes the current and voltage waveforms get closer to being in sync, which improves the power factor. From an electrical engineering point of view, the capacitive reactance of the capacitor opposes the inductive reactance of the load. By choosing a capacitor with the right capacitance, you cancel out some of the inductive reactance. This reduces the overall impedance phase angle, which is the measure of how much the current lags behind the voltage. When the phase angle gets smaller, the power factor gets closer to 1. That means more of the energy supplied is used for actual work and less is wasted. Practically, fixing the power factor with capacitors has many benefits. It reduces the amount of current needed for the same amount of useful power. This lowers the losses in the electrical system. It also decreases the demand charges from utility companies and helps keep voltage stable. Large industries often install capacitor banks to manage their inductive loads. These banks are sometimes controlled automatically to prevent overcorrection, which can cause the power factor to become leading instead of lagging. In summary, capacitors correct power factor by supplying leading reactive power. This balances out the lagging reactive power from inductive loads. It reduces the phase difference between current and voltage, making the system more efficient. This process helps save energy, reduces costs, and keeps electrical systems running smoothly.